Thank you. I think we're on the third and final leg of the triathlon, the Ironman. I know after this, I think we should turn on the disco ball. I just noticed it was there today. And start dancing on tables. My name is Donn Lee. I work for Facebook. Before Facebook, I was on the network architecture team at Google. That was back around 2004. And then at that time, we were only doing v4. So there wasn't a lot of v6 until we hired Lorenzo and Eric. And they started to look at v6 along with some other folks. And then before Google, I was with a company called Proxy Networks that was bought by Cisco, and before that I was with Cisco. And during that time I learned a lot about how to build routers, routing protocols, and working with customers who at that time were mostly in Asia who had v6 requirements, but also looking at what's the right way to scale routers and switching with v6. So my talk's about network engineering and content delivery at Facebook, and I'll give you an idea of some of the steps that we've taken with v6 and some of the projects that we have and where we're going. So this is kind of a really cartoon view of what we call the production network. This is the network that our team is responsible for. It is essentially everything in our domain that serves an IP packet for a Facebook user. So that includes the edge, where we interface with peering in transit to the internet. Our backbone, which is a global backbone of routers, and then which connects to all our data centers. And then within the data centers, we have heavy use of switches, load balancers, and of course servers. And looking at the whole landscape, and we thought about v6, and we had to kind of come up with some goals. What are we going to do with v6? Where do we want to serve it? How far do we want to go? What should be the first steps? So this was kind of like our first stab at the goals. We had a rather lofty goal, which is that we wanted to serve any Facebook user who is v6 capable the full Facebook experience. So in other words, a user should be able to go to Facebook over v6 with the v6 client and use the application, use the website, no different than how they do on v4. Of course, this requires that eventually, well, it requires on day one that the clients are dual stack, because there's quite a lot that's in the application that as in network engineering we can't control, and that's served over v4 still. But if the client was dual stack, then the application should just work. The other point is that eventually the end goal would be to serve all of the content over v6, and even before we can get to the work of doing that, we have to identify what has to be changed from v4 to v6. From a routing protocol backbone point of view, we decided to deploy ISIS. We were OSPF v2 initially, and that was when we had only 8 routers. So we kind of looked at the future and we said that, well, we know that OSPF v2 is not v6 capable. So we have to either go to OSPF v3 or ISIS, and we chose ISIS. And there's all kinds of backbone transition solutions out there. We decided to just go dual stack and not go with anything that was kind of in between. So dual stack on all the routers. And to scope the project down, we have thousands and thousands of servers. We're not going to touch the servers. So our goal was to make no changes to the servers, because that would have to involve a lot more departments than just network engineering. So we wanted to provide the first bullet, but not have to touch the servers as far as v6. And we have 2 projects that could serve Facebook to their users. Native v6, which is Project Chicago, and Lisp, which is not to be confused with the computer language, locator ID separation protocol, which can be used to serve v6, and I'll show you exactly how that's done, Project Cakewalk. So, back to kind of the view of the network. These are the areas where we deployed solutions for v6. And so the first part is, you have to have v6 connectivity. So for here, on the edge, where we already connected internet, we needed to have and we sought and we received v6 transit. And also a lot of our peers had already been asking us if we peer over v6, and at the time we were telling them, no, we're not ready. So we already knew that there were peers that, that were v6 capable, so we started turning them up as well. And that would give you, basically from a content provider view, the initial, very, very initial, not even toe in the water. It's kind of like the very tip of the toe in the water, which is you can receive a v6 table, that's always nice, and you can send a v6 prefix announcement, your v6 prefix. And then you can do really cool things like ping, and then once you do the ping, you're all happy for that day, mission accomplished, until you start wanting something more sexy than ping. After that, we deployed, or actually in parallel with that, ISIS on these routers, dual stack, and BGP, so that both the internal and external protocols could support a v6 routing. In the data center, we've got these three kind of families of building blocks. We went with v6 on the load balancer with address translation. Because again, remember, one of our goals was not to touch these thousands and thousands and thousands of servers, not yet. So we decided to implement 6 to 4 translation on the LB, not to be confused with 6 to 4, but the ability of the load balancer to terminate a v6 TCP connection and to provide that request, forward it to the servers that are ultimately serving that request over v4. And so I don't know how familiar you are with content providing or websites. Every website you terminate on, 99% of the time will be on a load balancer. And the load balancer is kind of, in my opinion, the unsung hero of the internet. They do their work quietly without getting much fame or credit. But almost every time you use or terminate on a website, you are terminating or going through a load balancer. And so these are very important components for us who run large websites. In a table form, this is essentially that cartoon, right? You have the network hierarchy, the different layers of the network for our environment, the devices that live there, and the solutions that we've deployed. And what I've added here on the far right is the kind of the deployment timeline of what we had to do in order to get to where we are now, which is day one, you have to have the edge connectivity. You have to have v6 transit and peering. On the backbone, you don't need to have that day one. In other words, if you have it on the edge, there's some tricks you can do to kind of keep v6 on the edge and still be able to serve the website to v6 users. So from the backbone, we took this organic approach where v6 is being implemented across the backbone, kind of like in a, starting with one region and then spreading out from there. So that's organic. In the data center, it's a very limited and very minimal deployment. And that's because we went with this load balancer, it's effectively load balancer only type of solution, which is that the only building block in the data center that had to be v6 aware was the load balancer. And then on the host, we don't have any plans to change the host to v6. It's not something that's currently on our radar. And in fact, there's none of the software engineers, the system administrators are asking me or asking for v6 on their servers. And these are backend servers that the users don't really know about. They're the workhorses that provide all of the pages to you. And they do their work, but they don't have to be v6 to serve that to you because they can be v4 within the Facebook network. So kind of the big step where we are now is, how are these large websites going to open the floodgates and provide dual stack web hosting to the internet, right? So yes, we all know as large content providers that we can start serving a quad A for www.facebook.com or www.largewebsite.com, and we will see a tremendous increase in v6 traffic. That's a given. So the question we always get is, well, why aren't you guys doing it? You know, what's taking you so long? So let me just kind of go back a little bit and say that what we haven't opened the floodgates. What we've done is we've provided a v6 specific URL. So the user has to intentionally type in a different URL to use v6, right? And that's how most of those websites are approaching v6. If you add, you know, the next step is to add the quad A for the main URL. And, you know, it doesn't have to be that exhaustive. Maybe it just provides a front landing page. Maybe you just do the front landing page as v6 and not worry about every single URL that the user could click. Because there are a lot, you know, possibly thousands of URLs within any one of these websites that need to be checked for v6 capability. In other words, if the user clicks a link within Facebook, eventually you want it to be served as v6. So why is it taking so long? Well, there's this kind of number that's being tossed around and more or less converged on the internet, which is 0.05%. So 0.05% of users, just a generic sampling of users on the internet, will be broken if I serve a quad A for Facebook.com, www.facebook.com. And, you know, when you look at it, you think, oh, 0.05%, that's pretty small. But if you do the math, 0.05% is 1 out of 2,000 users. And when you have 500 million users, 1 out of 2,000 users is a lot of users. And the fastest way I could lose my job is to start serving you a quad A, or serving the world a quad A. So that's the reason why large websites haven't yet turned on the quad A. Now they have, you know, we saw a slide yesterday where they have, like at Google, they turn on quad A for a certain period of time, turn it off. And I think eventually that's where it's going to have to go. The numbers are getting better though. So even a year ago, that number was higher. There's more broken clients. And the numbers in the most recent study I saw was that the number can be as low as 1 in 10,000 users in just a few months. And that's because Mac OS X is going to get a patch. So from a business standpoint, let me talk about this 0.05% in user failures. You know, you could say, well, you know, forget those users. But again, and they'll fix themselves, or the word will get out and we have to fix them. But it's not just up to me. There's a lot of people involved for these web companies. The big part is around user perception. You know, user perception is everything to a website. And so this means that the business people have to be involved, and that means the money people, the revenue people. If you get paid for a click, those people now care because you're taking out 1 in 2,000 users. And the product people care because now the user is going to the website or going to the application and there's brokenness. The page is either slow, noticeably slow, things don't load, maybe that all the kind of formatting, the CSS, all the things that make today's web pages beautiful is broken, and so the user gets essentially garbage on the screen. So all these other people have to be involved. So the larger your web company is, the harder it is to get to the point where you can serve quad A, because more and more departments and people who are responsible for the revenue get involved. So that's been kind of my observations about this whole question of opening the floodgates. So let's get to the practical steps of what needs to happen. Well, first we have to understand the blast radius on of quad A on these broken clients. There's a lot of good people doing this studies today. Google being one of the big front runners and researchers on this and advocates about how we fix the broken clients. You need to have good instrumentation of the user experience. So a lot of these websites have put in code where as you're using their website today, even though you're v4, they're trying to detect, you know, what kind of browser you're running, if you have the ability to load anything on 6 to 4, if you're running Teredo, et cetera. So being able to get the statistics to get an idea of like how many users could be affected by opening the floodgates. Testing is probably the biggest piece, and everybody's afraid to test because you can't really test in a lab this type of quad A brokenness. You have to turn it on, clients have to get broken, your website has to suffer, and remember, those clients can't reach you anymore, so you can no longer get statistics from them. So there's kind of this big blind spot that you have when you turn it on, and you can turn it off and then and ensure that things come back. So testing is a big piece. The one part that we are working on as a internet company community is kind of what's being called as IPv6 Day. I don't know, has anybody heard of IPv6 Day for next year, June next year? So we don't know what the final name is going to be, but essentially it's a day where multiple large popular websites turn on Quad A for a day, 24 hours, UTC time. We let it run. Hopefully things don't break terribly. And then, you know, we have, for the money people and the product people, we tell them, yeah, there's a backup plan. If it's really bad, we can back it out. But for that day, there's user awareness, there's ISP awareness, or people who have, you know, that support the users will be aware of this day. Perhaps there'll be some grassroots support for people. There'll be more press. And then ultimately, there'll be this day where if I go to Google and do Google search and it's broken, let's say that I don't know it's IPv6 Day, and go, gee, you know, that kind of stinks. I've never seen this before. And then I go to another search engine like Bing or Yahoo and do the search. That, oh, hey, well, that's also broken. Well, then there's some the user can think that, oh, well, maybe it's me, right? So today, you won't see somebody like any one of those 3 websites turning on Quad A because they are so afraid that if you do a search on their search engine, you immediately go, boom, never using you again, unreliable, going to any one of the other 2 guys. So that's kind of why testing is so hard. Everybody's afraid to turn it on, or not really afraid to turn it on, but I would say that the business people and the product people care so much to turn it on that the networking people and the people on the ops side and content side can't really turn it on. So that's IPv6 Day, or it'll have some name, and you'll get more communication about it. So then you need to have communication. We're not sure how that's going to work with the user. If the user is going to, you know, there's different ways you can do that. We are thinking about having little kind of scrolling messages to say that, hey, in 2 days, you're going to be broken. So just FYI, right? Because if you've done the instrumentation, you can kind of give the user a heads up. You may have URLs to click to help to diagnose and how you can fix your client. And taking this kind of leap in doses. So this 24-hour day in 2011, you know, that's kind of doing a dose and then having more iteration on that after we do analysis on it will be useful. So that's kind of the story on the content delivery side. Oh, I did have one on content delivery. So for content delivery, we care very much about the code, the code that runs and delivers Facebook.com to you. A lot of it is logging. So any piece of code that either reads a user log or writes to a user log today is essentially v4 32-bit aware, and probably is going to assume so. So now, you know, we have the job of going through all our code, and specifically, you know, logging is very particular to user because that's the piece that's external. Remember, our servers will stay v4, so we won't have to touch a lot of stuff like provisioning. We can still provision our servers v4. We can still alarm, you know, if a server's having a problem, we can still detect alarms over v4, which is nice. But for the user part, when the user changes to v6, our logging, the parsing, the storage of that has to be v6 aware. So that's a lot of code that has to be hunted down. A lot of geolocation for you, the client, is done over v4, based on your v4 address. And so geolocation will change because of users now coming in through v6. And you know, currently there isn't like this big, huge wealth of information for geolocation in v6 that we have in v4, but that will change over time. And we have a lot of tools. So essentially any tool that is assuming a v4 address has to be hunted down like a Y2K type problem and be made v6 aware. CDN, so a lot of us rely on third-party CDN networks, as well as our own privately built CDN networks. So all of the content, the big content that we want to see on v6 is going to be video and images, large data sets, not so much text. And a lot of that is very v4 anchored. So converting the CDNs to v6 is a huge win for v6. And then the broken clients, detecting them, repairing them. And there's a very good report, just hot off the press, by Tor Andersen out of Norway, that I'd like to share with you. So the URL is there, but I'll just give you a quick idea and synopsis of what it is. It's called IPv6 dual stack client loss, which is exactly what us large websites care about. This is the broken client problem. He sums it up as two main causes in his studies. The first is old Opera web browsers, which when you look at his data, and he actually specifies it's not that much. There aren't that many people with old Opera web browsers. Opera web browser users have upgraded with Opera over the quarters. But probably the biggest part of client loss or client brokenness is today Mac OS X. Popular operating system, and it has this behavior where it prefers 624 over v4. So one of the things that and he turned this on for a day, so he had his own kind of IPv6 day, a 24-hour day test. And his client loss was not 0.05% that is commonly bandied about, but very close, 0.06%. 0.06% of the clients would be broken if he left Quad A on. And he has a nice little graph here. And if you look at this graph, it was worse at the beginning of this year, but now it's hovering at about 0.05%. It's nice also that he gives this breakdown of how the v6 users are reaching him. A lot are native. Next would be 6 to 4. And I was very happy to see that Teredo was almost 0. Yeah, so yes, I did not want to see that the Teredo graph was going up. If anything, it looks like it is going down, but it's quite a bit lower than 6 to 4, which is good news for all of us. And native is above 6 to 4. So I thought that breakdown was very valuable. When he takes Mac OS out of the equation, this number comes down to 0.01% right here. You can't see it, but I have the URL there. But it's 0.01%. So when Mac OS gets this patch, which is believed to be slated for 10.6.5, we will have removed a lot of this concern of websites breaking, of Quad A breaking clients to websites. And then he has this client loss without, yeah, we're here, with Mac OS excluded, which is a lot less. So this starts to get us in about the 1 in 10,000 kind of range. So if you have 500 million users like Facebook, 1 in 10,000 is about 50,000 users, which starts to feel to the business and product guys, I sure hope, that, okay, you know, maybe those guys are people that hacked their PCs, they're power users, they are experimenting with 624 or whatever. It's not the default setting, or they're tweaking their home CPE equipment because they were enthusiastic about v6. And there's some bug that is breaking. But we believe that probably will no longer be kind of the default setting like it is for Mac OS. So let's see if there's anything else. Oh, Opera. He breaks down the Opera. Opera browsers before 10.5, I believe it says here, had problems with the Quad A, but they no longer do. So he does a study of how many old Opera browsers came to his websites. And then he provides a huge wealth of resources to learn more. So if you want to learn about why content providers are not turning on Quad A, this is probably the most recent, hot off the press last week, data, as well as a very good resource for you to branch out and get a lot of extra technical information. So I'll pause there. I'll pause there to see if there's any questions about what I've said so far before I go into our specific solutions with V6 and Facebook. Yeah, Stan.
You estimated the impact of carrier grade NAT as it's implemented on the problem that you've expressed?
So the question is, have we been able to estimate or analyze the impact of carrier grade NAT on users using the website? No, we haven't. So we haven't had any good access to carrier grade NAT type of data. In my personal experience, we've been studying a lot about the different approaches for carrier grade NAT. And it seems like we will be okay with it so long as the people providing the carrier grade NAT are also the people who answer the phone when the user has a problem. I think those seem pretty well coupled from presentations I've seen. So as long as that happens, I won't worry too much about it, because then kind of the product delivery and the support and the SLA will go hand in hand. But it is something that we should get more data on. Yeah.
Once you enable the v6.facebook.com, you notice like traffic metrics.
Oh, traffic on. So the question is like, after we turn on V6 for the special V6 URL, how's the traffic been? Actually, I haven't looked at it lately, but I could probably bring up a graph after this talk. It usually happens that we get a spike after a V6 conference. And then it kind of goes down a little bit, but it's always higher than it was before because people are tweeting about it or updating their status saying, hey, I updated my status for V6. Or it gets in the press saying, hey, Facebook just turned on V6. So that was kind of the biggest step. I don't remember the statistics offhand, though. Yeah. Oh, right. So the question was, are you running ISIS and OSPF in the core? Oh, no, I wasn't clear. We migrated away from OSPF and we converted the backbone to ISIS. Oh, we did like kind of the standard way, which is you turn both on and then you switch the forwarding to V6 rather than turn OSPF off. Yeah, so OSPF was turned off shortly after we verified that there's no hiccups. But you could use OSPF v3, a lot of people do. Ed? Right.
Is that something you're actively doing, or is that like, we're just going to wait for,
Right. Are we turning on like a pixel image over to V6 to get the statistics of who's broken? So now, yeah, so that's actually where we are now, is that I've got the software people on board, the people who care about servers and the code. So with their cooperation, we are going down this path along a lot of lines of what Tor Anderson has published in that URL I did, which is to start collecting this data and keeping historical statistics on the users that are, possibly have like an old version of Mac OS or are broken or coming in through Toreto. So we don't do it today in the website, but it's something that currently is an active project, and we have regular, like, not meetings, but we have regular conversations about. We try to avoid the meetings because people are pretty busy coding, but we are very busy with coding for that purpose and logging it. So after we were able to prove that we could do this capability, I then got the software people involved.
So you're going to use that to actually be able to talk and tell people, hey, your old is that literally
right.
how you work with them? Say, hey,
yes.
you are broken, you need to go fix yourself, and you have a hack. We were able to detect that.
Right. Yeah, so for the broken, so through this study, when we do turn it on, because again, we have to do this before this 24-hour day that we're going to do. So we'll have statistics, and then we will know, at least based on what we do know, which clients are broken. Based on what has proven to be definitely broken clients, we can send them a little message when they use Facebook saying, hey, in 2 days you're going to be broken. Hey, in 1 day you're going to be broken. because when we actually break them, we won't be able to talk to them anymore. So we will know the user, and the good thing about our service is that you have to log in, you have to have a password, it's your identity, so you can start to do that, and maybe as a result of this message, they might even say, like, did anybody else get this weird message about v6? Because I don't know technology, you know, I'm a non-technical person, and then maybe their friends can like kind of help them with that message, or we'll have a link to say, go click here, and then we'll do kind of like this little like kind of red light, you know, you're definitely broken, or yellow light, you might be broken, you might be using Opera, you might be using Mac OS, or well, you are using Mac OS in this old version, here's how you upgrade. So we can help the user. But definitely alerting the user will be useful for gathering this data, but we have to gather data first, which is important to us. Was the question that, do I have any predictions of how much or how many users are going to be using v6? No, I don't. Because again, I don't have the kind of the 1 pixel image data that tells me how many users are. A lot of websites are farther along, so they do know like how many users are coming in or would come in through 6.4 or Toreto or native. But I don't have that data for my users right now. That's why this measurement piece is so important for the opening of floodgates, because we don't know how many users and how much bandwidth we're going to have. We know the bandwidth will probably be low because a lot of our images, which is a big part of our data sets and video, will continue to be served over v4. So as far as capacity, I'm not worried about the floodgates being so big that they're going to overwhelm anything network-wise or server-wise or load balancer-wise. Because we are doing the kind of piecemeal part where we're going to serve kind of the HTML through v6, and then the user will still have to be dual stack to get things like photos and videos. So that is actually a good segue to the next point, which is, well, I just said a CDN, but you know, a lot of folks use third-party CDNs. We pay, you know, thousands of dollars a month for CDN providers to serve images for our users. So you know, it's a big part of it. That, though, can come later because we first want to make sure that the users aren't broken. Okay, so I just have a couple slides on specifically our solutions, like what we've deployed, and things that you can do, or if you have friends that run websites, what they can do. So the first part I mentioned was address translation. This, to us, was really easy and a very nice solution. The load balancer provides out of the box, no cost, 6.4 translation, and it doesn't require any different configuration than a v4 IP address. So the load balancer has this thing called a virtual IP, and that is the IP address when you go to www.facebook.com. That address that you get back is an IP address, but it's a virtual IP address. It's not actually an IP address of one server. It's an IP address that lives on a load balancer that has thousands of servers behind it. So now you can just do the same configuration, and instead of making the virtual IP address a v4 address, you make it a v6 address, you're done. The nice thing is that the thousands of servers that actually support that virtual IP and live behind that virtual IP, all those can remain v4. The load balancer just will translate it automatically. So it's no configuration, no cost. It's perhaps the easiest thing you could do. You do have to have connectivity to the public v6 network, internet. So that's where the edge piece comes in. But within a data center, I thought this was like one of the best things we ever did right here for getting the initial port online for our v6 VIP. So here you see this 2620. This is the VIP or virtual IP for our v6 URL, which is www.v6.facebook.com. And what it will do is when the user terminates on this IP address, it will forward the address to a web server, and that web server will have a tenant address. You know, we don't use errand space for numbering our servers. It would just be a waste. All our web servers are addressed out of private IP space. So now the hosts or servers can remain v4 for now. This takes literally like half a day max to do. And yet it's so powerful because if you think about it is once I have the v6 peering in transit, I've now provided a large website to this now orange, yellow cloud, the whole v6 internet.
I have a quick question. Do you
Yeah.
actually turn on 64 on the load balancer and turn your farm, or do you use a separate load balancer to have that and do it in production load balancer?
So the question is, this load balancer, do we actually do this where you have the load balancer going to the servers as a separate farm, or do we have this load balancer point to other load balancers? Yeah, right. So in reality, what we do is we point the v6, so what we did is we got a v6 load balancer which was decommissioned. It was essentially a load balancer that in the old days was big, but by today's standards and for the traffic we need, it's not so big. So it was sitting on a shelf. We knocked the dust off of it, turned it up. It's the same operating system as our current modern LBs or big, humongous LBs. And we pointed it to the existing v4 LBs. So this picture is not exactly how it's implemented at Facebook, but instead of going directly to the servers, which is one approach, we have it going to the v4 load balancers, which is this slide here. We have these v4 load balancers that serve all of Facebook.com, the heavy load for all of our v4 Facebook.com traffic. These are the production v4 VIPs. So our v6 load balancer simply points to those guys. I believe we terminate SSL on the v6 load balancer. I haven't confirmed that. This is the part that my colleague Will Lawton did. But yeah, the other approach is you could, if for example your servers are v6 specific or you want them to be v6 specific for some reason, you can have a separate pool of real servers behind this serving it over, of course, private address space. Now, we chose to use the production server farms because the great thing about it is we don't have to sync code. We don't have to say, we got this v6 server farm here and the v4, and we just put a bunch of v4 patches in the v4 one, and somebody has to be responsible for syncing it. We don't want to be responsible for syncing it. So the nice thing about pointing to the existing production is that if the user goes to v6 at home and then goes to work and uses v4, that Facebook experience will be identical because the code is identical. And it's automatically synced, so nobody has to do any extra work. So I'll talk about this other project, which was using Lisp, Locator ID Separation Protocol, for serving Facebook.com, similar to our native v6. The same goals as our native v6 project, but there's a twist. There's a networking twist to this. So here we have the production v4 load balancers. We have our Facebook private backbone, and then, of course, we had the public v4. Now, Lisp is a project spearheaded largely by Cisco. It's an IETF working group. It's got different applications. You don't have to use it this way. You can use it in a data center. You can use it for mobile. If you're interested, I encourage you to check it out. This is a specific use case for Lisp and how you can deliver v6. So the Lisp project has these routers out there on the internet. These are Lisp-only routers called Proxy tunnel routers. Lisp works because of this encapsulation technique that it does. I won't go into the details, but I'll give you just kind of the basic solution. These routers already exist. You don't have to pay for them. There are people that are part of the Lisp development community, IETF working group, and they have donated routers that do this thing called proxy tunneling. Okay. So we looked at it and we said that, you already have these deployed. Could we, and they said, by the way, they're connected to the public v6 internet. Go, interesting. Could we use those guys for free to reach the v6 users and serve Facebook.com? And they said, yes, it's really easy. Here's how you do it. So it took about 4 hours in total, which is nothing in a network project kind of time horizon. And we had to deploy this thing called a tunnel router of our own. And then we had to have another load balancer for v6. Now, we could have used the same one we did for native v6, but in this case, I wanted complete separation. So I got another dusty, old, decommissioned load balancer, put v6 on there. And in the same way, it's a simple v6 translation to v4 for the production VIPs, virtual IPs back here. So what did it cost me? Well, the tunnel router was donated to me by the Lisp team as part of proving out this use case. Load balancer was free because it was dusty, it was decommissioned. We already had errand space. We weren't using it except to send out a prefix and to accept pings. So we said, well, we'll turn this on here, this little v6 space, in addition to our native. And the nice thing about it is the only place we had to configure v6 was on this load balancer and one interface of the tunnel router. So this project required a total of 3 IPv6 addresses and 4 hours of my work. And it was essentially just a little pet project. But at the end, we were able to serve all of the v6 users. And so here's how it works. So v6 only required here. You'll notice something here. I didn't have to turn on ISIS. I could have stayed OSPF v2. I didn't have to touch any of my servers. Didn't have to touch my production load balancers. I did have to add this little thing called a tunnel router, which essentially is a Cisco router running special image that can do Lisp. And the extra configuration lines in iOS was around 8 lines of Lisp-specific configuration. But you notice that actually I didn't have to change even my edge. For this solution, I don't have to get v6 peering or transit. And I don't have to touch my backbone or the data center. So here is how it works. Basically, the user comes in. And best thing of all, the user doesn't have to touch a thing. The user just has to have v6 connectivity to the public v6 internet. So the user comes in through v6 and says, I want to go to www.lisp6.facebook.com, gets a quad A. It gets routed to the proxy tunnel router. This proxy tunnel router is specifically advertising my Lisp address, my Lisp address, the quad A. So it's attracting all of this Lisp traffic. And it says, oh, hey, when it peels off the v6 address, when it intercepts this v6 address, it says, do I know how to reach this v6 address through Lisp? And it says, why, yes. I can access this v6 address over Lisp, but using v4 only. So it goes, to get to this v6 address, I have to use v4. So it puts the v6 packet inside a v4 packet, encapsulates it, again, transparent of the user, and routes it over the public v4 network to my tunnel router. So that's the key step, is that the proxy router knows the Lisp site, because I've configured this tunnel router, and my tunnel router says to reach this quad A address, you have to encapsulate to this v4 address. My tunnel router gets the v4 packet, peels off the v4 address, looks inside and sees a v6 address, and like any v6 router says, do I know how to reach this v6 address? It says, well, yes. It happens to be attached to this Cat5 cable directly attached to this load balancer. Well, of course, it doesn't know this MAC address, and ships it over to the load balancer. Load balancer says, do I know this v6 address? It is me. 6-to-4 translation, ship it. You're done. So that's how we used Lisp. I actually have a talk that is all about just this slide on Lisp that I do for a Lisp type of segment. But the important thing is that if you want to, if somebody put the screws to you and said, and twist your arm and said, you got to get this website on v6 to the v6 users this time next week, this is one way you could do that, right? It doesn't take much time. It requires 3 IP addresses and about 4 hours of work just to deploy the router and plug it in, and about 8 lines of additional configuration on the router. And you can get up and running, and you wouldn't have to worry about the client doing any type of special thing in his house or anything with the ISP or having any special type of code. You could rely on these already deployed proxy tunnel routers. So it's experimental network, but it can be done. And since the traffic isn't that much right now, and there's actually a lot of redundancy, they deployed a lot more proxy tunnel routers and they watch the utilization of it. As the utilization goes up, they can beef up the proxy tunnel routers and supply more of them. So that was another solution. All right, so that's what it is. This is the address. That's the URL. If you have v6, you can use this. And again, the only reason why you know it's Lisp is because it's in the URL. Other than that, I could call it foo.6.facebook.com or something. It would just work if you're a v6 user. Those are the URLs. If you have a v6 mobile address, you can use the m.dot version of the website as well. Impress your friends, become the star of the party. I encourage you to do it. Got this awesome phone that's more advanced and more modern than yours. It's experimental, non-production. So it's a best effort type of service for us. If the power goes out, or if my load balancer blows a fuse, I won't know about it until somebody contacts us. Our address is IPv6@facebook.com if you want to reach us by email. And yeah, please use it and give us your feedback. So with that, I'll thank you for being an attendant audience this late in the conference. And if there's any questions, I'll be happy to take them. Thank you. Yeah, Ed. So the question was, is it a way to get around 6-to-4 and stateful tunnels? And what were the reasons for you to do this? There were actually a couple of reasons. Most of the reasons were all for fun, actually. Because we had an interest in Lisp. We actually did Lisp 4. So we have www.lisp4.facebook.com. So if you're v4 connected, you can use Lisp over v4 in the same way from your current laptop right now. So it was a simple additional VIP to just add on v6, and the big payoff was to be able to reach v6 users. For example, like if we couldn't get the native v6 up and running in time, we did get both of these up, I think, in the same week, actually. Then we would have this, and we could name this www.v6.facebook.com, and people would really not know unless they did a lot of research. So most of it was to see if we could do it. It was a pet project, and it was to see if this use case could exist, because up until this point, we didn't know of any large website that was serving v6 users over Lisp. So we wanted to see if we could prove it, and it does work, and learn from it and provide feedback to the Lisp IETF working group members. So there wasn't like a compelling need. We didn't have any motive like, oh, if 6-to-4 is broken, then we can use this. I mean, there's certainly a lot of ways you could now, if you have motivation, we've shown that can be done. There are ways that you can do this kind of transparent 6 over a 4 infrastructure just by doing this. Because you would, the only twist is that you have to participate in Lisp, which is no problem, it's free. But you just have to now turn on the Lisp router instead of what you might do like with a 6-to-4 relay router or something like that. So it's another way to skin the cat. And I think v6 has shown, to me at least, that it's very open to people with transition mechanisms. So there's another one for your cookbook, I guess. Right. So the question is, in my Lisp slide, it only showed one entry point for Lisp to the proxy tunnel router. What about redundancy or scale reliability? What happens if it breaks? I show one, but there are multiple. So how does it find the nearest one? It's simply just like any other routing. it's a prefix that's advertised by multiple routers. So you would go routed to the best one, and best would be determined by BGP. So is it superior than a classic tunnel broker scenario? I don't think I have enough experience with tunnel broker to know or to deem that. But I can say that the proxy tunnel routers, there are multiple ones and they're spread around. There may not be as many of them though, compared to the tunnel brokers. And it's not specific to v6, it just uses traditional BGP routing announcements. So in that way, it just leverages all the traffic engineering and redundancy or recovery and convergence of BGP. It's because it's simply just a prefix announcement, and you will go to your nearest one. Because all of those proxy tunnels routers will emit the prefix to reach our Lisp site. Does that answer the question? Okay, so best one via BGP. Great, thank you.